We have a sample problem here. A simple pendulum makes 31 oscillations in exactly 65 seconds. What is the length of the string? So a simple pendulum, omega is the square root of g over L. G being the acceleration of gravity, L being the length of the string. Again, simple pendulum means that all of the mass is concentrated at the end, and so L is the length of the string. We know omega is 2 pi f. Omega is in radians per second, f frequency is in oscillations per second. So our frequency, just in terms of units, 31 oscillations in 65 seconds. So that is our frequency. So let's see, let's go ahead and solve our equation symbolically. If I square both sides, that leaves me with g over L on the left, and then 2 pi f is all squared. We're looking for length, so I need to cross multiply, and the length ends up being g over this 2 pi f squared. So 9.8 meters per second squared over 2 pi times 31 over 65. The 65 is in seconds. This needs to be squared, that whole quantity. All right. So we have 2 sig figs, so I will round this to 1.1. Our units are meters, and you can see that by following the units in the problem. The seconds that we are squaring now in the frequency are canceling out with the second squared in g, and that leaves us with meters. Total side note, be very careful with problems that are worded similarly to this. I mentioned before, it's really easy to mistake frequency and period. It's good to always pay attention to the units. Frequency is always oscillations per second, where period is the number of seconds in one oscillation. So had we wanted to write in terms of period, we would have said that it takes 65 seconds to complete 31 oscillations, so that we would end up with our units of seconds. It's just a common mistake that I see. That's why I bring it up. Watch the units. That's the best way to go to know whether you have frequency or period.